Hello students, welcome to Sources classes. This video is ISI 2020 subjective solution, which you are waiting for a long time. So in the past videos I have solved it from 1 to 6. So from this video I will be solving from 7. So here is a right angle triangle, integer valued sides a less than b less than c, and pairwise co-prime. So what is co-prime? For example, 5 and 7, 2 primes, they are co-primes as well. But 5 and 26, both these are one prime, one non-prime, they are co-prime as well. And 9 and 28, these two are non-prime but co-prime. So if the HCF between them is 1, there is nothing common there. So D equal to C minus B, suppose D divides A. Okay, in this way, so prove that D less than or equal to 2 and find such triangles with perimeters less than 100. Okay, so the first part is easy, second part is a little bit tricky. So let me add a page here. Okay, so Pythagoras said a square plus b square equal to c square, long time back. So a square equal to c square minus b square. So c plus b, c minus b, so c minus a here, c minus b will be d, so d equal to c plus b. Now d square divides a square by d into c plus b. Okay, so a square divides this, hence d, the divisibility pattern can be written in this way. So c plus b we can take as kd, and d plus 2b equal to, we can take kd again. So 2b equal to k minus 1 into d after equating. So now let we can take p greater than or equal to 3. Now it's a prime factor of d. So now as a result of that, p also divides d, p divides b, and consequently p divides d plus b equal to c, but b and c are co-prime. So we get a contradiction over here. So the only possible prime factor of d is 2. This is the only prime factor. Remember that every number can be broken into prime factors. Okay, so the same reasoning we can show that the power of 2 in the prime of factorization d is at most 1. So we have proved that either d equal to 1 or d equal to 2. So now at d equal to 1, c equal to b plus 1, b square plus 2b plus 1 equal to c square equal to a square plus b square. So a square equal to 2b plus 1. This has been done. So it follows that a is odd. It follows that a is odd. So a equal to 2k plus 1. So 4k square plus 4k plus 1 equal to 2b plus 1. So b equal to 2k square plus 2k. So we have a equal to here, so a equal to 2k plus 1, b equal to 2k square plus 2k, c equal to 2k square plus 2k plus 1. So the perimeter of this is 2 plus 6k plus 4k square less than 100. So 1 less than, if you just solve it, will give you this. Now corresponding triangles, possible triangles also we need to calculate over here. So the combinations of the triangles will be either 3, 4, 5, 5, 12 or 13, 7, 24, 25, and 9, 40 and 41. Let then the next case d equal to 2. So c equal to b plus 2. So b square plus 4b plus 4 equal to c square equal to a square plus b square. So a square equal to 4b plus 4. So it follows that a is even. So a equal to, we can take 2k. So here 4k square equal to a square equal to 4b plus 4. So b equal to k square minus 1, c equal to k square plus 1. So if for k equal to 2, a greater than b and k is odd, so b is even. So a and b are non-coprime, not CP. So in this fact, k equal to 4 and 6 we can take. So the corresponding triangles will be 8, 15 and 17 and 12, 35 and 37. So the 6 triangles that satisfy this equation is these 2 and these 4. So total 6 is the answer. Now we move to the last question. The question says that a finite sequence of numbers is said to be alternating sequence if a1 greater than a2, a3 less than a4, a3 greater than a4, a4 is than, so this way or exactly the opposite. So how many alternate sequence of length 5 with distinct numbers can be formed such that ai for this thing is valid? Okay, so let's see where we can go with this. So here we will say that a permutation is being useful here, a permutation of a1, a2 dot 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 an for a set of 1, 2 dot 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 n. Okay, so this thing is like alternating a1, a2, a2, a3 in that way. Another permutation of a1 is another alternation. So this is like a1, a2, a2, a3 in that way. So corresponding a1, a2 dot 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 an, this thing, if we correspondence we go, so that will give us n plus 1 minus a1 comma dot 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 n plus 1 minus an. So this is a 1-to-1 correspondence between the set. So 1-to-1 corresponding between the set, and this, if we just say mark it as 1 and 2, so with respect to 1 and the 2 permutation. Now an, let an denote the number of the cases in the cases in 1. So 2an is the number of alternating permutations we have, just the double. Now once we have it, so now we need to consider an alternating permutation, which is like a1, a2 dot 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 an. So let ak equal to n, so that this values are like ak minus 1 less than ak and ak greater than ak plus 1. So now as given that k, if k equal to even, so then obviously a1, a2 dot 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 ak minus 1 with respect to 1 will have k minus 1 numbers. Okay, therefore a of n minus k different permutations. Okay, and in the other side a k plus 1 dot 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 an will have the second, so that will have n minus k. So a n minus k in this case is the second set of permutations. Okay, so first set, second set clear. So now we have there are n minus 1 c k minus 1 ways to split 1 2 dot 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 n minus 1 into groups by k minus 1 and n minus k elements. So obviously 2an here will be a summation n minus 1 c k minus 1 a k minus 1 into a n minus k. Now as it is being done, obviously it is k equal to 1 to n. So since a0 equal to a1 equal to 1, so we compute that a2 equal to 2, so a2 is 1. And 2a3 is 2a2 plus 2a1 square. So a3 from this will give you 2. So this was 4. Okay. Similarly, 2a4 equal to 2a3 plus 6a1 into a2. That is equal to 10. Putting these values will give you 5. 2a5, 2a4, 8a1 a3 plus 6a2 square. So this is a4, 5, 10, 30 and this square, so like 32. So 32 different permutations of the set of the 5 numbers. So we can choose these numbers in the set like 1, 2, ... 20 if we have. So 32 into 20C5. 32 into 20C5, 20 factors. So we can leave it like this here. So this is the total structure.